Web applications run on HTTP, a protocol that is inherently stateless. To build a functioning system, you have to establish a way to recognize a user from one request to the next. This identity management is a core requirement of web development, yet the mechanics of how it functions are frequently misunderstood. Most developers can implement a basic login system by importing a library and following a standard implementation guide. But in a system design interview, when asked to explain the specific mechanics of state or to justify an architectural choice, many candidates struggle to articulate the underlying logic. This friction usually centers on three distinct paradigms: sessions, JSON Web Tokens, and OAuth. These are often viewed as a menu of competing options. In reality, they function as complementary layers that address different parts of the authentication lifecycle. By looking at how these systems handle data and memory, we can build a comparative framework for choosing the right architecture for a specific set of system constraints. Mastering these mechanics allows you to design systems that remain secure and performant as they scale from a local prototype to a distributed global network. Authentication must solve for the fact that HTTP has no memory. When a server fulfills a request, it has no native way of knowing if the next request comes from the same user. The traditional solution begins when a user submits credentials. The server verifies these against a record in its database. Upon verification, the server generates a unique session ID, storing it in memory or a database. The server sends this ID back using the HTTP set cookie header. Browsers automatically attach this cookie to future requests, requiring no custom developer code. This is a stateful architecture. The server must actively look up the incoming ID against its internal records to identify the user. The burden of maintaining state sits entirely on the server's memory. As traffic grows, you must distribute the load across multiple servers. If a user session is stored only on server A, but their next request is routed to server B, that second server will have no record of the user's identity. To resolve this, you must implement a shared session store that every server can access. This introduces central database dependency and increased network latency. Sessions offer high levels of control, but they create a memory lookup bottleneck as applications transition from a single server to distributed services. In distributed systems, relying on constant database lookups for every request becomes computationally expensive. JSON Web Tokens, or JWTs, provide a stateless alternative to this problem. A JWT consists of three base64 encoded parts: a header defining the algorithm, a payload containing user data, and a cryptographic signature created with a server-side secret. The server signs the data and sends the token, storing no copy. On future requests, the client attaches this token to the HTTP authorization header. The receiving server mathematically verifies the signature using a local secret, authenticating without a database query. This makes the system stateless. The server relies on computation rather than stored memory to confirm the user's identity. This efficiency leads to a specific architectural consequence: the loss of instant revocation. Because there is no central database entry to delete, a JWT remains valid for any server that sees it until the token reaches its encoded expiration time. JWTs allow for horizontal scalability by removing the need for server-side state, though they require shorter expiration windows to manage security risks. A common misconception is that OAuth is a direct alternative to the session or JWT models. OAuth is designed for delegated authorization, allowing a third party to verify a user's identity on your behalf. It allows users to log in using an existing account, like Google or GitHub, without ever revealing their third-party passwords to your application. When initiated, your app redirects the browser to the external authorization server. After approval, the server sends a temporary authorization code back to the browser, which forwards it to your app. Your server then exchanges that code directly for an access token. This access token is used only to fetch the user's profile information from the third-party provider's API. This demonstrates the boundary of the protocol. OAuth manages the verification of the identity, but it does not manage the ongoing state of your specific application. Once your server confirms the user's identity via OAuth, it must still issue its own session cookie, or JWT, to keep that user logged in. OAuth provides the external identity verification, while sessions and JWTs provide the internal state management. These mechanics allow us to build a decision framework for choosing an architecture during system design. Session-based authentication is the standard choice for monolithic server-rendered applications. This model is necessary when the system requires the ability to instantly revoke a user's access. If a security event occurs, deleting the session record in the database terminates access immediately. JWTs are the preferred choice for microservices, mobile apps, or APIs that serve many different clients. They are used when horizontal scalability and reducing the database load are prioritized over the ability to perform instant, centralized revocation. OAuth is implemented specifically to allow users to authenticate using existing accounts, removing the friction of creating new credentials. System designers select these tools based on the specific trade-offs between server-side control and distributed performance. These architectural patterns map directly to common software libraries. Session management is often handled by middleware like Express Session, which automates the generation of IDs and the parsing of incoming cookies. JWT implementation relies on libraries like JSON Web Token for the secure signing and mathematical verification of tokens. OAuth flows are frequently managed by libraries like passport.js, which abstract the redirect cycles and token exchanges. You can pause here to see how these libraries handle the different stages of the handshake. Each of these systems typically operates as middleware, functions that intercept and verify requests before they reach the application's core logic. If this helped clarify these architectural patterns, subscribe for more technical deep dives. To see how these authentication checks are implemented at the request level, watch the next video on how backend middleware functions.